Hey guys, Buildzoid here, and today we're gonna be in a mess of a video, because let's just like I don't know what I'm doing with this. Like I want to show something that is very hard to show, which is why this motherboard is like sideways. It's running right now. This is running. Yeah, it's supported by literally these two standoffs. So it's great. Well, to be fair, also like the AIO is counterbalancing the motherboard, and the GPU is counterbalancing the motherboard, but perfect test setup here. Also, the lighting is incredible. Anyway, what's going on? So the board here is the Gigabyte Z590 Pro AX, and in preparation for my PCB breakdown, or like, well, so I've been working on my PCB breakdown for this board, and I also saw a review of this board from Overclock3D.net, and in his testing, it was running like way too hot. In my opinion, he was hitting like over 100 degrees on the VRM, and I was like, there's no way it runs that hot, right? Like, this is a 12-phase Vcore VRM. It uses 90 amp smart power stages. How the hell is it getting over 100 degrees Celsius? The VRM, if you're like, how the hell is it getting so hot? So I decided to do my own thermal testing, which, like, verify. Like, with some motherboards, I don't bother because I think it's pointless. But with, if I see somebody else being like, hey, this runs hot, and I'm like, well, it shouldn't. So yeah, we're gonna go test that because like, maybe it does run hot, right? And it does run hot, unfortunately. But the thing is, like, what I don't get is, like, why does it run hot? It doesn't make any sense for this board to hit over 100 degrees Celsius. Like, these are 90 amp smart power stages. There's 12 of them. With the load that we're currently running, I actually managed to get I've straight up gotten the board to thermal throttle. So the way I'm running the board right now is we have a 10900K in there at 5 gigahertz with a 1.27 volts die sense voltage right now, and it's running Prime 95 small FFTs. As of right now, the VRM is at 94 degrees Celsius, so I actually timed that perfectly. And we've got the multimeter here because so obviously you've got your power stages, right? You can lose power in your power stages, but then once the energy, once the current goes through the power stages, it still needs to travel all the way from the power stages over here to the CPU over there. Unfortunately, the AIO does have the backplate, so we can't actually measure the voltage in the center of the CPU socket, which is what I ideally would have wanted to do. But instead, we can just rely on the motherboard's own socket reading, which currently the motherboard is reporting that the socket is sitting at 1.34 volts, and well, die sense is at 1.27, so we have like a 70 millivolt voltage drop across the CPU socket, which in my experience, that sounds correct. And then, well, we'll get to the voltage loss in the power plane very shortly. But the interesting thing that I noticed when I still had the motherboard horizontal on the test bench, and I was just going around it with the IR thermometer, is there seems to be like a really nasty hotspot in this VRM where it's like really hot in just one place, and the rest of it's actually at reasonable temperatures. So if we go down here, right, that's like this lower half of the VRM. It's currently at, okay, that I was reading like the back. But yeah, like this lower area of the board, like this is fine. There's nothing really wrong with this area of the board. I wish I had an like thermal camera, but those are really expensive. So that's fine. If we measure behind like so you can see I'm putting the dot right on around where the power stages are, which actually, wait, there. So yeah, so we have a few that are now at like 100 degrees, but what I find really interesting is look at the power plane. That's not the VRM. That's the power plane. That's this area in between. Like, this is your capacitors. This is the CPU socket. That's the capacitors. Like, the VRM is, like, the power stages are over here. The inductors are, halfway between those two things, between the capacitor legs and the power stages. And the hottest part of the board from the back is not the VRM, it's the power plane. So, which, yeah, like, And it's not like the CPU is at like 115 degrees or something. I mean, the CPU is at 108 degrees, but that is still lower than the temperature of the power plane. So like it's you can't like if the CPU is at 108 degrees, if the CPU was heating up the power plane, it is physically impossible for that power plane to be at a higher temperature than the CPU, right? But what's actually going like this is hotter than the CPU. It's hotter than the VRM. So it's like so evidently we're just burning tons of power getting from the VRM to the socket, basically. Is what that looks like to me, and we're going to check that with the multimeter as well, because we can just check the voltage at the capacitors versus the voltage that we get in the like socket sense from the motherboard. Which right now the motherboard is reporting that the core like the socket sense core voltage is like 1.35 1.334 volts. So let's take some capacitor voltage measurements. For the bulk capacitors, which are like the first component after the inductors. And man, this is going to be so awkward. I really hope I don't break the board. At least it's not mine. Thank you, Gigabyte, for providing motherboards for me to complain about. So, you know, the socket, according to the motherboard's measurement system, is at 1.34. That cap is at 1.44. So between the voltage measurement point is somewhere in the middle of the CPU socket, or at least it should be. So between like this area right here and there, we have 100 millivolts of just power loss. Like bye-bye. That's electricity that's just gone into heat. And we are currently, according to the monitoring of the motherboard right now, the CPU is sucking up over 270 amps. So if you do the math on that, 100 millivolts multiplied by 270 amps is, you know, like that's 0.1 volts times 270 amps, right? So we are losing 27 watts of heat getting from the VRM to the CPU, which is... which would explain how so right now the VRM temperature, according to the motherboard VRM temperature sensor, so actually it's not the motherboard VRM temperature sensor, it's the temperature sensor inside the actual power stages, right? Because this uses 90 amp smart power stages, so the temperature reading from the VRM is actually from inside the power stages. The power plane's at 120 plus degrees, right? It's at 125 degrees and rising. Meanwhile, if I measure behind the power stages, that's 116. And if we go on the 12-volt power plane, that's at 85. Like, we need power plane heat sinks. Yeah, we need freaking power plane heat sinks. Also, the motherboard's about to start thermal throttling, which is yeah, that's a thing. What else did I want to show you? Anyway, another way we can look at this is the motherboard is reporting that it's pulling in about 420 watts of power right now, which I've actually measured that it does pull basically that much power. So keep that in mind. Motherboard claims that it's pulling in 420 watts. It says the CPU is pulling 347 watts. Okay? What we're going to want to do is, and it says that the VRM is outputting 270 amps. So we're going to take our 270 amps, multiply it with our 1.44 volts, and we get about 388 watts. So if we go 420 minus 388, we get about 32 watts of heat. Which is still high. That's like significantly above what the power stages should be losing. But actually we can, like, it might have managed to, like, the thing is, as the operating temperature increases, the VRM efficiency goes down, so... Also, the power plane resistance goes up, the hotter the power plane is, so the voltage is gonna... Like, basically, the hotter it runs, the hotter it gets, the hotter it gets. Because the hotter it is, the more power loss there is. So we have some capacitors that are almost at 1.45 volts. Issue being that, you know, like... Oh no, that's the iGPU again. Oops. And that one's at 1.46, so yeah, that's great. So, I don't know, there's not really a great way to... Because, you know, each phase is supplying a portion of the current overall, but... there's a lot more, like, the output voltage of the VRM is way above the voltage that the CPU is actually getting. And if the motherboard is to be believed, also way above the voltage the socket is receiving, which is like, oh, yay. Yeah, I wonder why the board's so hot. Actually, let's check again. What's the power plane at? It's cooled off a bit, because the thermal throttling... not really. And then behind the power stages... Right, like... And this lower portion of the VRM is ice cold. Because the Vcore pins in the socket are sort of... The Vcore pins in the socket should be right around this area. Because normally iGPU power comes in through the top. Vcore comes in through this side. So most of your current... Like, basically a lot of the current should be doing something like that, depending on... Depends how the power plane is designed. Unfortunately, it's not like I have schematics. I don't expect a Gigabyte to give those to me. And even if they did, it would be under NDA, so I wouldn't be able to show you anything. So, you know, kind of pointless for me to have them. But, yeah, I don't really know what the point of this video was. Because, like, I mean, this is something I think I've kind of mentioned in passing occasionally in videos, that, you know, like, power planes, pretty important. It's just that I didn't think we'd have such a drastic example of that, like, here, with this board. Because, yeah, like, it runs, like, this area of the board runs really hot. And then, like, like, the thing is, that heats up the VRM, which is why the VRM temperature reading... Because all of that heat that goes into the power plane, that's just, like, the power plane's... Well, the power plane is just copper. Actually, the whole PCB is just a copper fiberglass sandwich. So any heat that gets generated in the PCB is just going to spread through the whole thing, and it's going to heat up the CPU, it's going to heat up the VRM. So, power plane heat sinks. We need power plane heat sinks. Or more layers. That's sort of the only two ways I'm aware of like improving this, or like a bigger power plane, but I'm not really sure how you how you could get that. Like, I don't know what the schematic looks like. So maybe, you know, internally the Vcore power plane is actually horrendous, but like, looking at the board from the top layers, it looks fine, or at least it doesn't look significantly different from like other top of the line Z590 boards. Or like, well, it doesn't look like there's anything inherently wrong with it, and then it's like you run it, and it's just like there's a hotspot right here, and the funny thing about having a hotspot right there is that there is no VRM over here. So it's like, how is this getting hot? So yeah, I guess now you know, like, power planes also, you know, it's really cooling off now. Oh no, I'm just bad at pointing the thermometer. Alright, and then if I just slide back... I wish I had a better way of doing this. I wish I had an IR camera. If we had a... like, theoretically... Like, what I... The thing is, because obviously with this... Like, I wanted one of the ones with, like, two dots for aiming. But, those were more expensive. And I was like, do I really need that? And now I'm like, I should have just gone, like, full-blown IR camera. Instead of just this. Because, yeah, this is, like, one of those areas where like, I don't like using IR camera. Like, I don't like IR cameras for doing, like, VRM thermals, because it's just, like, just measure it with, like, K-types. Like, IR camera is great for finding the hotspot, and then you should use a K-type thermocouple to measure it. But this is, like, a perfect example of, like, it's not the VRM. Like, this is sort of what IR thermal cameras are, like, perfect for, is, like, something's getting hot, but it's not the thing that's supposed to be getting hot. So, yeah. Like, and I'm not sure, like, The thing is, if you put a fan on the board, you can get the VRM temperatures under control just fine. But yeah, it's just like we are shoving a lot of power. Like I am shoving a lot of power through the CPU, but it's just I don't know what to make of this. All right, like that's the thing is like what am like this is a $290 board. And basically, like, to be fair, like, I'm running Prime 95 small FFTs on it. I don't have any airflow. Actually, let's remove the airflow restrictor, see if that does anything. I doubt it'll do anything. The AIO is, like, this was blocking all the airflow from the AIO from reaching the board. Is that going to make a difference? No, that doesn't really seem to be. Well, maybe. Yeah, no. Nah, it's still sitting at 115 degrees. The thing is, at the same time, this board, in my opinion, makes most sense if you're running like an 11600K. Well, like, this is such a weird, like, yeah, I don't know. Like, I don't know what to say. Because, like, it runs hot. Like, it's not debatable. It does run really hot. And sure, it's not the VRM's fault that it runs incredibly hot, but at the end of the day, it does run incredibly hot. And, oh no, it is cooling down a bit. Or it's just thermal throttling again. I'm not sure at this point. It seems to have like a 2-degree VRM thermal throttle hysteresis. So like once it hits 115, it throttles back until it goes down to like 113 or something, and then it goes to full power again. So it really rides the thermal limit, but yeah. Also, I wish I had better test equipment. Oh, we've hit 126 on the power plane. I'm right up against the board because, oh, whoa, we got 127. And I'm measuring here, like, it's not the VRM. It's not supposed to be on 100. Like, yeah, I don't know. Like, I literally don't know what to say about that. I mean, this is an issue I'm aware of. You know, this is something I do know about, but it's just like, I never thought we'd see it on a board that's $290 with 6 layers. I mean, to be fair, like, well, now that I think about it, I don't think I've really done similar comparison tests on other boards. But man, this is such an annoying thing to test though, because you have to have the board bloody sideways. Because like from the front, if you have a AI, like if you have a water block on the front, you're not measuring anything. And like the worst news about it actually being the power plane that's getting crazy hot instead of like the VRM. Whoa, you can feel it. Like I can feel the difference with my finger. Damn. Okay. Anyway, like I'm not touching it, like just being near it, you can tell that this area is producing more heat. But anyway, like the thing is like that's actually roasting the capacitors directly, right? Like that's the most fragile component in a VRM is the capacitors. It's not the power stages. The power stages, the power stages, if the power stages were left to their own devices, their own internal thermal limit is set to like 125 degrees or something stupid like that. Actually, no, it's 150. Yeah, it's these are 158 degrees Celsius thermal limit on the power stages. When you hit that, they will wait until they cool down to I think 130 if I remember correctly, and then they'll go right back to running at full like they're going to go right back to running potentially. Depends how the VRM is implemented. But the internal thermal limit for the power stages is 150. The capacitors, on the other hand, those are rated at 105. They're not rated for 125 or like anywhere near what the power plane is hitting. And actually, taking the airflow restrictor from the AIO has managed to cool down the board a bit. So now we're at 111 degrees on the VRM. So Yeah, but that really, like... And if I measure where the VRM is? Well, yeah, that's the thing. I'm not sure where... Like, theoretically, these caps right here, this row, is supposed to be right on the ground and the 12-volt, like the ground pad of the power stages, and then on the 12-volt side of the power stages, because these are 12-volt input filtering capacitors. Um, but, yeah. So board runs hot, but if you have airflow, it doesn't really like. Well, if you have airflow, it still runs hot. It just runs less hot, and it's not the VRM's fault. I want to. I'm like, wait. Like at this point, you can leave. This isn't gonna go anywhere. It's just like I'm just like I refuse to believe that they could like seriously the power plane. Are you kidding me? Okay, so 1.44. Do I have an average? Oh, wait, the thermal throttling really screwed that over it. Okay, wait, I'm going to reset the monitoring data. Going to get myself a new average. So, yeah, it is like 270 amps. So 270 times 1.44. No, 44. And the VRM says that right now it's averaging about 400 watts of input power. Unfortunately, the input power monitoring has been really buggy for me. Like for some reason, it regularly drops down below like 260 watts, even when it's not VR. Like even when the VRM isn't thermal throttling, like even if it's running just fine, it drops down to like 200 watts for some reason. I'm really not sure why the input power monitoring is doing that. And unfortunately, like my current clamp is garbage, by which I mean this. This thing is like the difference between my multimeter and this current clamp is like ridiculous. That thing is so bad. It's like really nice. Actually, it's kind of like this multimeter is probably the most like high-end test equipment I have, because my oscilloscope is also like basically the cheapest oscilloscope with as many features as possible. So the current clamp is a similar situation, which, yeah. Anyway, so 388 coming like that's coming right out of the VRM, and man, I don't trust the board's average input power draw reading. Like 390 watts sounds correct. Actually, no, it doesn't, because then we wouldn't have... Because here's the thing, right? Like, the difference in the voltage between the caps and the socket, that's the power plane power loss. Then the difference between the socket and the die sense is the socket power loss. And then the difference between the power going into the VRM and the power right at the output, that is the efficiency of the VRM. So if the motherboard says we had as up to like peak input power was 417 watts. So if I take 417 and subtract that 388, we get 29 watts, which is still a little bit on the high side for what the power stages plus inductors are supposed to produce in terms of heat. Like on paper, at this kind of current output, this VRM should be producing about 20 watts of heat, but 29 is close enough. It's much closer than, you know, if you take the input power versus the output power that the VRM's reporting, because the VRM does the VRM reports output current times die sense voltage, right? Because the VRM doesn't monitor the voltage right at the capacitors, it measures the voltage right at the CPU. And the die sense voltage is like 1.26 bloody volts. So the VRM is reporting like, oh yeah, we're you know, like the VRM says you have like, oops, you have like no 417 coming in, and then what the CPU actually gets, and I meant the minus sign, the CPU actually gets 344. So there's like 73 watts of power. Like there's 73 watts of power loss between, you know, the 12 volt side of the VRM and the actual die. And so if we take my, you know, my, well, actually, we could just do the 1.44 minus 1.26. Multiply that by 270 amps. That gives us 48 watts. I need a second calculator. I've just realized. Actually, no, I don't. We'll just remember this. So 48 watts. And the other figure was 417 minus 344. Minus 48.6. Yeah, that's actually... So this is roughly in line with how much power I would expect the VRM to actually be dissipating. And then all of the rest of the heat loss is the power plane. So I feel reassured in my VRM like performance calculations that they're like accurate, because I have because the thing is, power stage and inductor power loss is what I go like the PCB breakdowns are like power stage and inductor power loss. And it doesn't factor in power plane power loss because, like, what am I supposed to, like, how you can't look at a board and go, oh, this power plane's going to lose 50 bloody watts when you shove 200 amps through it, right? Like, I wish you could. I'm pretty sure there's some simulation software that could do exactly that. But yeah, just looking at because you'd need schematics at that point, right? Like, you'd need schematics, like actual like layer, like the whole layer stack up and everything. And from that, you could calculate how much power you're losing from the VRM to the CPU. But just looking at the board is kind of like, yeah, no, you're not going to be able to do anything about that. So anyway, I don't know. Like, this video is going nowhere, but like, is the board bad? I guess. Yeah. Is the... Well... like, the thing is, the main feature of this motherboard is that you get 4 M.2 slots. And I feel like people who are file copying enthusiasts, right, because they need 4 M.2 slots, they probably don't care about running Prime 95. So it's like, on one hand, I'm really disappointed that like a VRM like this with, you know, 1290 amp power stages gets this hot. On the other hand, it's like, from a sort of like it's cool to see a power plane lose that much power. Like, not in a good way, it's just interesting. Like a car crash. Or a plane crash. They make documentaries about those, so you can't argue with me on that one. People legit think those are interesting. But yeah, I don't know. Like, it's not a cool running board. I'm really, like, the thing I don't get is, like, how is it possible that it's the power plane? Is this a regular occurrence? Will I be testing, like, multiple Z590 boards where all of them have a power plane that loses more, like, where you lose more power in the power plane than in the actual VRM itself? Is that, like, a regular occurrence? Because admittedly, I didn't really test any low-end Z490s, so maybe it is. Maybe that is an actual major issue. Or maybe Gigabyte just borked the power plane on this thing. Right? Like, there's two options. Like, either this power plane is just bad, and this is not a regular thing, or it is a regular thing, and we just need, like, 12-layer boards. Oh, man. You do not want 12-layer motherboards to become the standard. They would be so expensive. Like, so freaking expensive. Also, I'd really like to have somebody else confirm my testing here. Yeah, that's what I really wish. Because it's like, I have a suspicion, and I can't really see anything wrong with my test methodology in terms of, like... Also, the VRM is managing to cool down. It's now at 109 degrees. Whoa, I'm so... I want to check again. Oh, look, the power plane's at just, like... Wait. No, it's still at 124. How is it so hot? Also, there's bits of the VRM that are still... Well, of course, there's bits of the VRM that are still way above the temperature of the freaking internal temperature sensors. So... Yeah, I don't know. Maybe you could have like a heat pipe that runs from the VRM heatsink in front of the capacitors. Then there's like a thermal pad to the power plane. Man, that would be such a nightmare for like CPU cooler clearance. Oh, maybe you could have a CPU heatsink that like connects with a thermal pad. Like it overhangs. No, that's also awful. That's also like that would fix it, but that is an awful solution. What I'm thinking is like you could have a CPU heatsink design where it overhangs the CPU socket so much that like you can put thermal interface between the power plane and the CPU heatsink, and then the CPU heatsink also cools the VRM like the Vcore power plane, and it's like yeah that would work. It's just that like that is jank AF. Like imagine putting thermal paste on your motherboard. It wouldn't actually be thermal paste; it'd be like thermal pads or something, but. Actually not or something. It would literally just be thermal pads, maybe thermal putty. But yeah, I don't know. Hopefully you found this video interesting. Like I found it interesting to test this. I've made a really bad video about it. Yeah. Like, I wonder if it's fixable. On the other hand, it's like, it's also one of those things, it's just like, yeah, this might be fixable with, like, a PCB revision, maybe? I don't know. But it's like, does Gigabyte care to fix this? I don't think so. I mean, if we run, like, a more normal workload, this really isn't a concern, right? Like, I have the CPU at what? Actually, the CPU has now cooled down a bit because... Like the thing is the power plane heats up everything around it. So it heats up like so you know if you cool like as the VRM cools down, the VRM is now capable of sucking more heat out of the power plane, so less of it has to go into the CPU. But yeah, it's just it's not cooled down much, but it has cooled down a bit. It's just I don't know. Let me know. I'd love to hear your thoughts on this. And of course you can fix this with a fan, right? At the end of the day, if you have any kind of cooling problem, be it power plane or VRM, you can always throw a fan at it. Unless it's really, really bad, in which case even the fan won't help. And there are situations where like legit there are certainly motherboards where no amount of fan or airflow is going to fix the VRM situation, but this is not one of those. If you put a fan on this, the VRM ends up sitting at 86 degrees Celsius. Or, well, it also depends on what fan you use, right? I used one of these because I have tons of them. And so, yeah, like with one of those, I can get the VRM down to 86 degrees Celsius. So this is like a board where they legitimately could have included a VRM fan. But they put it on a high-end board instead. Also, you could do like a weird like shroud thing through the VRM heatsink so that like the fan, like the airflow is directed up like down towards the power plane, right? Like you'd have the fan. Anyway. These are the kinds of dumb ideas that make me go like, ooh, might be like it would be kind of cool to work at a manufacturer. Except I'm pretty sure they would never implement any of these ideas because it's just like how to make your motherboard way more expensive to produce for no good reason. Though fans are cheap, right? Like fans are cheap. Just look at X570 motherboards and how all of them have fans. So something similar for like power plane cooling or just overall VRM cooling wouldn't really be a problem for low end boards in my opinion. Well, anyway, yeah, this is really going nowhere. I should just end this video. So I guess thanks for watching. Sorry for wasting your time. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. Don't actually leave suggestions. I don't like your suggestions. Well, I don't like most suggestions. Most suggestions are awful. Uh, if you think you're the exception, you can make a suggestion. You probably aren't, but go for it. Um, and yeah, so Gigabyte, I'm sorry, but like, I guess I don't like this motherboard very much because it runs way too hot for like what it is. And also, I'm 99% certain. Like, I want to blame the power plane for this, because I don't know. Maybe there's something wrong in my like measurement methodology here, but like, it legit isn't. Like, it's getting hot here, not there. The VRM is not over here. So what else could possibly be getting hot? It could be the ground plane, but like, you're supposed to, as far as I know, you're supposed to have on like a 6-layer board like this, there should be an internal like massive ground plane. There shouldn't be like that should actually have like, that should be better. That should be lower resistance than the power plane under like the vast majority of circumstances. So yeah. There. Okay. Now I've actually said everything. So yeah, thanks for watching. Oh wait, no. If you'd like to support what I do here with the channel, there's Patreon, there's Teespring, there's links to that down in the description below. Yeah, Teespring, merch store, Patreon, just support me directly each month. Yeah, would be much appreciated because it helps acquire test equipment. And yeah, that's it for the video. Thanks for watching, and goodbye.